side marked X. Here's X. First thing you need to realize is that this is a right angled triangle. We've got one length, one angle, and one unknown length. We could use the three trigonometric ratios, so Toa, to help us answer this question. First step, label your triangle. Okay, with respect to this angle, this is the opposite side. This is the adjacent side, and this is the hypotenuse. Hypotenuse is opposite the right angle. Now you need to decide which of the trigonometric ratios you're going to use. Well, you're given the angle, you've got the adjacent side, and your question is to work out what the hypotenuse is. Which of these ratios has both the adjacent and the hypotenuse? We don't need to be dealing with the opposites. The only ratio that has both the adjacent and the hypotenuse is the cosine ratio. Here's your adjacent, here's your hypotenuse. The others have the hypotenuse but not the adjacent, or have the adjacent but not the hypotenuse. So this is the rule we're going to use. Write down your ratio. So cosine of an angle theta, could be any angle, is equal to the adjacent over the hypotenuse. Fill in the information that you know. Theta is our angle, which is 20. And that is equal to adjacent. Do we have adjacent? Yes, adjacent is 12 centimeters. And the hypotenuse is x. We don't know what that is. So we've got everything. Remember from the lesson that cos 20 is a number. You can put that into your calculator and write it all in and solve it, but it'd be easier to just leave it as cos 20. Now, to solve this, we need to multiply both sides by x to get rid of this x, and you're going to be left with x, the angle that we're trying to work out, times cos of 20 is equal to 12. And divide by cos of 20 on both sides to get rid of that cos of 20. Divide by cos of 20. And these will cancel out. You're left with x is equal to 12 divided by cosine of 20. And if you put that into your calculator, so 12 divided by the cos of 20, and that gives 12.77 centimeters to 2 decimal places. So our length here is 12.77 centimeters. And that is it. Example 2 is asking us to work out what x is. Okay, now we are shown that x is 5.142 centimeters decimal place, but let's work it out and see if it's correct. Again, write SOHCAHTOA. Next step, label your triangle. This is going to be opposite with respect to the angle. Hypotenuse, and your adjacent is here. Decide which of the ratios you're going to use. Step 2. We have the hypotenuse. We need to find out what the opposite is. And we have the angle. Okay, so the only ratio that has both opposite and hypotenuse, so here's your hypotenuse, here's your opposite, is the sine rule. Again, check, look, there is the hypotenuse but no opposite. Here is the opposite but no hypotenuse, so it has to be sine. So write it down. Sine of 40 is equal to opposite over hypotenuse. Sine of 40, fill in the information that you know. Opposite is x, here's your opposite. We're going to call it x, the length that we don't know. And the hypotenuse is 8 centimeters. And now solve. Times by 8 on both sides to get rid of this 8. And it's going to leave us with x, so times by 8 as well. And you're going to get 8 lots of, or 8 times sine of 40 is equal to x. And 8 times sine of 40 into your calculator, x is 5.142300877 centimeters, which is equal to 5.142 centimeters to 3 decimal places. And that's the end of this question. Example 3. Calculate length of the side marked x. So here's x, here's 8. With respect to the angle we're given, this is the opposite, this is the adjacent. Now we don't need to write hypotenuse because we don't need to deal with that. So the only rule that has both the opposite and adjacent is tan, which is TOA. So tan of theta is equal to opposite over adjacent. So the first one is opposite over adjacent. Fill in the information that you know. We know theta is 34 degrees. Opposite is 8. And adjacent is x that we don't know. To solve this, we need to get x on its own. So something like x is equal to. So times by x on both sides, times by x. This gets rid of the divide by x. And we have x times by tan theta, 34 is equal to 8. Now the next step is to divide by tan of 34 on both sides, divide by tan of 34. This gets rid of this times by tan of 34. So you get x is equal to 8 divided by tan of 34. Okay, 8 divided by tan of 34 gives you 11.8608487775, which is equal to 11.861. So this was wrong. Oh no, it was right. 8.4. So 860 centimeters to 3 decimal places. And you've worked out what x is. You can draw it onto your triangle if you wish to. And that is it. Okay, the homework you'll be given is something very similar to this. In fact, question 3A is the first question on your homework. Read the question. Calculate the length of sides indicated by letters in each of the following triangles. Give each of your answer correct to 3 significant figures. So it's asking us to work out x and then y, or y and then x. It doesn't matter which order you do it. So, with respect to your angle, let's say we want to work out what y is first. Okay, with respect to the angle, this is the opposite, and the length that we're given is hypotenuse. So to work out what the opposite is, we need the sine rule. So, O and H is the sine rule. So sine of 50 is equal to the opposite, which is called y. We don't know what y is, over the hypotenuse, which is 12. So if we want to work out what y is, we have to do 12 times the sine of 50, which is equal to y. So 12 times sine of 50, and y is equal to 9.19 to 3 significant figures. And make sure you put your units. Now, to work out what x is, I'm just going to write 9.19 here, centimeters. Now, to work out what x is, we can use two methods. The first method is using this trig ratios, which is the most accurate, which I recommend doing. So method 1 is actually using the trigonometric ratios, which is SOHCAHTOA, or we could use Pythagoras. Why we could use Pythagoras is because we've got two lengths and one unknown. We've got the hypotenuse and we've got we've got one shorter length. We can work out the other shorter length. Method 1, which is the trig ratios, so trigonometric ratios, so trig for short, ratios, which is SOHCAHTOA, is the most accurate method. We'll see in a second. So, pretend, okay, go back into question. Now, this, to work out what x is, I'm going to use a different colour, green, to work out what x is. Well, x is the adjacent with respect to the angle, and go and use the hypotenuse because we are 100% sure it's 12 centimeters and it's the most accurate. 9.19 is rounded to 3 significant figures. It's not very accurate. So using that, we need to, well, decide firstly which ratio we're going to use, and it's the cosine rule because we've got the adjacent and the hypotenuse. So the cosine of 50 is the adjacent over hypotenuse. Fill in the information that you know. So cosine of 50 is adjacent is x. The hypotenuse is 12. And simply times by 12 on both sides. So 12 times the cosine of 50 is equal to x. So 12 times the cosine of 50, and x is equal to 7.713451316. On your calculator, that's all I see on my calculator, which is 7.71 centimeters to 3 significant figures. Now, method 2, using purple, method 2 is the Pythagoras method. So when we've worked out y, we've got 9.19 and the hypotenuse is 12. So if we use Pythagoras, which is a squared plus b squared equals c squared, or the hypotenuse squared, this would mean that 12 squared minus 9.19 squared is equal to x squared, that we don't know. And solving for x on your calculator, so do this, then square root it, would give you 7.716464, which in fact isn't that bad. It is equal to 7.72 to 3 significant figures, but it is very close to the most accurate method, which is the trig ratios. I would suggest to use the trig ratios even though you can use Pythagoras. In fact, Pythagoras isn't too bad as well when you've worked out the lengths. So you can see you can either use method 1 or method 2. Both answers still give very similar results in terms of accuracy. So it doesn't matter what method you use when you've got the two unknowns, even though you worked out one of the unknowns using trigonometry. Homework is going to be this question, question 3. Remember, work out one unknown, label it properly, and then either use Pythagoras or use trigonometry.